Given limit extends to infinity, e upon 1 minus e into 1 upon e minus x upon 1 plus x whole to the power x is equal to alpha. Then we need to find log alpha upon 1 plus log alpha. So let us consider f of x is equal to e upon 1 minus e into 1 upon e minus x upon 1 plus x, and g of x is equal to x. As limit extends to infinity, your f of x will give the answer as 1 and g of x will give answer infinity. So anyhow it is in the form of 1 power infinity, which is indeterminate form. So for this, let us use the formula exponential of limit extends to infinity f of x minus 1 into g of x. So let's find f of x minus 1 separately. F of x minus 1 is equal to e upon 1 minus e into 1 upon e minus x upon x plus 1 minus 1. So we can write e upon 1 minus e into 1 upon e minus x upon 1 x plus 1 into e upon 1 minus e minus 1. That is 1 upon 1 minus e minus 1 minus x upon x plus 1 into e upon 1 minus e. So if we simplify 1 minus of 1 minus 1 plus e, that is e upon 1 minus e minus x upon x plus 1 into e upon 1 minus e. So if I take common e upon 1 minus e, so we'll get 1 minus of x upon x plus 1. So which will get e upon, so you're getting f of x minus 1 is equal to e upon 1 minus e, and here we can write x plus 1 minus x, that is 1 upon x plus 1. So this is f of x minus 1, so into g of x, that is f of x minus 1 into g of x, which is equal to e upon 1 minus e, this is a constant, into x upon x plus 1. Now as limit extends to infinity, e upon 1 minus e into x upon x plus 1, we can write limit extends to infinity e upon 1 minus e into x upon x taken common 1 plus 1 upon x. So as x tends to infinity, 1 upon x tends to 0. So we can write here e upon 1 minus e into 1 upon 1 plus 0. So we can write this as e upon 1 minus e. And hence now, so when you consider exponential, that is e to the power limit extends to infinity, so we got the answer as e to the power e upon 1 minus e, which is given as alpha. Or apply log on both the sides, so we get e upon 1 minus e is equal to log alpha to the base e. So that 1 upon 1 plus log alpha, which is equal to 1 plus e upon 1 minus e, which is equal to 1 upon 1 minus e. Therefore, log alpha upon 1 plus log alpha, which is equal to e upon 1 minus e divided by 1 upon 1 minus e. So we can write answer is e. So we can go with an option D, option 4. E is the answer. Given that the number of terms in an arithmetic progression is 2k, where k is a natural number, and if the sum of all odd terms of the AP is 40 and sum of all even terms is 55, and also given the last term of AP exceeds the first term by 27. So let us consider the AP as A plus D, A plus 2D, and so on. since the number of terms is 2k, so we can write a plus 2k minus 1 of d. And sum of all the odd terms means the first term plus third term, that is a plus 2d, and next term a plus 4d, and so on. We can write up to a plus 2k minus 2 of d. These are the odd terms which is given sum as 40. So we can simplify. So here total k terms are there. So a plus and so on k times. So let me write separately a plus and so on plus a. So this is k times plus again d taken common. So here we'll get 2 plus 4 plus 6 plus and so on up to 2k minus 2 of. So here we can say that if I take 2 common, 2d taken common, 1 plus 2 plus 3 plus and so on k minus 1. It's a sum of k minus 1 terms. We know sum of n natural numbers is n into n plus 1 by 2. So sum of k minus 1 terms we can write k minus 1 into k minus 1 plus 1, that is k divided by 2. So finally we can write ka plus k into k minus 1 of d, which is equal to 40. Let's say this in equation 1. And similarly, sum of the all even terms means second term, that is a plus d, next a plus 3d, and so on a plus 2k minus 1, that is last term, 2d, which is equal to 55. So here a also having k times, so we can write k times a, and d taken common, we'll have 1 plus 3 plus 5 plus and so on 2k minus 1, that is k odd numbers, which is equal to 5. And we know sum of n odd numbers is n square. Sum of first n odd numbers is n square, so we can write here sum of k odd numbers ka plus d into k square, which is equal to 55. So here we can also write the first equation k square d minus kd, which is equal to 40. Now let us consider this as second equation. Now subtracting 1 and 2, let us subtract first equation minus second equation. So we get ka gets cancelled and k square d gets cancelled. So we have minus kd is equal to 40 minus 55, that is minus 15. So we can write d is equal to 15 divided by k. Let's consider this as an equation 3. Now also given the last term of the AP exceeds the first term by 27. The last term of the AP, that is a to k, that is a plus 2k minus 1 of d, is equal to exceeds the first term, that is a plus 27. So here a and a gets cancelled and 2k minus 1 into d value is 15 upon k, which is equal to 27. Or we can write 15 2s are 30 minus 15 upon k is equal to 27, or we can also write 30 minus 27 is equal to 15 upon k. So 30 minus 27 is 3 is equal to 15 upon k, or k is equal to 15 divided by 3, that is k is equal to 5. So we can go with an option. The value of k is 5, option 4. Given point P 4 comma 4 root 3 be a point on the parabola y square is equal to 4ax, and PQ be the focal chord of the parabola, and if M and N are the foot of the perpendiculars drawn from P and Q respectively on the directrix. It's a directrix equation. Then the area of the quadrilateral PQMN we need to find. Since the given parabola y square is equal to 4x and one of the point is given, so we can substitute 4 root 3 whole square is equal to 4 into a into 4. So we can write 16 into 3 is equal to 4 into a into 4, that is 4 4s are 16 gets cancelled, so we can say a is equal to 3. So we got the parabola equation y square is equal to 12x, 4 into 3 into x. So we got the focus 3 comma 0. And we know that if one end of the focal chord is 80 square comma 280 parametric form, then the other end can be taken as a by t square minus 2a by t. So here a is equal to 3. So we can say 80 square is equal to 4, which implies t square is equal to 4 upon e, that is 4 upon 3. That is t is equal to 2 upon root 3. So therefore, the vertex q we can write a by t square minus 2a upon t, which is equal to, so a is 3 divided by t square is 4 by 3, comma minus 2 into 3 divided by 2 by root 3. So that is 9 divided by 4, and here we can write 3 root 3 minus 3 root 3. So we got the point q 9 upon 4, 9 upon 4 and minus 3 root 3. So here the y coordinate is minus 3 root 3. So we can consider this is minus 3 root 3. That is minus 0 comma minus 3 root 3 is n. 0 comma minus 3 root 3. And m can be taken as 0 comma 4 root 3. So the distance mn is equal to, we can find the distance mn is 7 root 3. And to get the quadrilateral, so here it is clearly a trapezium. Area of trapezium is MPQN or PQMN, which is equal to half into product of sum of the parallel sides, that is MP plus NQ, and into the distance between the two parallel sides, that is MN. So which is equal to half into MP value is, so we can say the distance from M to P is, so here 4 units and here it is 3 units, because the directrix equation just opposite to the foci, that is minus 3. So the equation of directrix is minus x is equal to minus 3. So we can say 3 units and 4 units, 7 units is MP, and NQ value is, so here 3 units and Q value is 9 by 4. So 3 plus 9 by 4. So into MN, MN is distance is 7 root 3, which is equal to 1 by 2, 7 plus 3, 20, 7 plus 3, 10, 10 4 is 40 plus 9, 49. 49 by 4 into 7 root 3. So we can say 49 sevens are 7 nines are 63. 7 4 is 28 plus 6, 343 root 3 divided by 2 4s are 8. So 343 root 3 by 8 units, square units. So which is option C. Given that alpha, beta, gamma and delta be the coefficients of x power 7, x power 5, x power 3 and x respectively, in the expansion of x plus root of x power 3 minus 1 whole power 5 plus x minus root of x minus 3 whole power 1 whole power 5, where x is greater than 1, and if u and v satisfy the equations, alpha u plus beta v is equal to 18 and gamma u plus delta v is equal to 20. Then we need to find the value of u plus v. So let us consider y is equal to under root of x power 3 minus 1 for some time, so that the expansion x plus y whole power 5 plus x minus y whole power 5. So we can write 5c naught x to the power of 5 y power 0, 5c1 x to the power of 5 minus 1 4 y power 1, and so on. 5c2 x to the power of 5c5 x to the power of 0 y to the power 5, and again added with 5c naught x to the power of 5 y power 0 minus 5c1 x to the power of 4 y to the power 1 plus and so on minus 5c5 x to the power 0 y to the power 5. Now by adding these both, we can get 2 times 5c naught x to the power of 5 plus 5c2 x to the power of 3y square, next 5c4 x to the power of 1 y power 4. So we can see that the power of y is even in all the three terms, and here y power 0, so that we can add 2 times 5c naught value is 1 and 5c2 value is 5 factorial by 3 factorial into 2 factorial, that is 5 into 4 into 3 factorial divided by 3 factorial into 2 into 1. So we can say 5 2s are 10. 5c2 value is 10, and 5c4 value we can write 5 factorial by 4 factorial into 1 factorial, that is 5 into 4 factorial divided by 4 factorial into 1, which is 5. So here 5c0 we can write 1, so we can write x to the power of 5, and 5c2 value is 10 times x power 3 into y square. Since y is equal to root of x power 3 minus 1, so we can write here x power 3 minus 1 plus 5c4 value is 5 times x into y power 4, we can write x power 3 minus 1 whole square. So here we can write 2 times x to the power of 5, or we can take the inside 2. So 2x power 5, and here we can write 2 times 20 times of x to the power of 6 minus 20 times of x power 3, and here 10 times of x to the power of 4. So here this term we can write x power 3 minus 1 whole square, x power 6 plus 1 minus 2 times of x power 3 into x. So we can write 10 times x power 7, and again plus 5x, sorry 10x and again here 2 5s are 10, 10 2s are 20, 20x to the power of 4. So when comparing coefficient of x power 7, alpha is equal to 10 and x power 5 coefficient is beta. So x power 5 terms only one is there, so beta is equal to 2 and x power 3 coefficient is gamma. So gamma is equal to minus 20 and x power 1 coefficient, that is 10. So we can say delta is equal to 10 and also given alpha u plus beta v is equal to 18, which implies that is 10u plus 2 times of v is equal to 18 and next one gamma u plus delta v is equal to 20, which implies gamma is minus 20 times u and delta is 10 times, so 10 times of v is equal to 20. So these equations by solving, and we can also write here 5u plus v is equal to 9 and here minus 2u plus v is equal to 2. So subtracting this both, 5u minus of minus 2, that is 7u is equal to 7, so which implies u is equal to 1 and substituting here u is equal to 1 here, so v is equal to 9 minus 5, that is 4. So v value is 4, therefore we need to find u plus v, that is 1 plus 4, which is equal to 5. So 5 is the answer, which is option D. Given ellipse x square upon a square plus y square upon b square is equal to 1 and hyperbola x square upon capital A square minus y square upon capital B square is equal to 1 and at the distance between the foci. So foci of ellipse, let us consider E be the eccentricity, small e is the eccentricity of the ellipse and E dash is the eccentricity of the hyperbola. So we have foci AE comma 0 and plus or minus AE comma 0 and for hyperbola capital AE dash comma 0 and it is given the distance between the foci of ellipse and hyperbola be 2 root 3. So we can say that both AE comma 0 and AE dash comma 0 both are same. We can say 2AE is equal to 2 root 3 distance between the foci and similarly 2AE dash is equal to also 2 root 3. So we can write AE upon AE dash is equal to root 3 upon root 3, which is 1. So E upon E dash is equal to A upon A small a. And also given the difference between the two values A minus capital A is equal to 2. And the ratio of the eccentricities of ellipse and hyperbola, that is E upon E dash, is 1 by 3. So 1 by 3 is equal to capital A upon small a. So here we can write small a is equal to 3 times of capital A. Substitute this small a is equal to 3 capital A. So here, so we can write 3a minus a is equal to 2. So that is 2a is equal to 2. So which implies a is equal to 1. When a is equal to 1, small a is equal to 3 times of 1, that is 3. So we got the small a and capital A. Now we know that AE is equal to root 3. So E is equal to root 3 and small a value is 3. So we can write E is equal to root 3 upon 3. That is root 3 upon root 3 into root 3 we can write, which is equal to 1 by root 3. Similarly, capital AE dash is equal to root 3. So we have capital E is 1, so E dash is equal to root 3. And now we have the relation in the ellipse B square is equal to A square of 1 minus E square. So which is equal to A square is 3 square 9 times of 1 minus E square value is 1 upon 3, which is equal to 9 into 3 minus 1, that is 2 upon 3, 3 to the 6. So B square value is 6, and capital B square is equal to capital A square of E dash square minus 1, that is 1 square 1, and root 3 whole square is 3 minus 1, that is 2. So capital B square is 2. Now to find the sum of the lengths of the lattice rectum, so we can say the sum is equal to sum of the lattice rectums is 2b square upon small a and 2 capital B square upon capital A for hyperbola. So that is 2 into b square value is 6 upon a value is 3, and 2 times capital B square value is 2 divided by capital A value is 1. So here we can write 2 2s are 4 here and plus 4, 4 plus 4 8. So sum of the lattice rectum of both ellipse and hyperbola, we can say 8, which is option D, option 4. Let the curve z of 1 plus I plus z bar of 1 minus I is equal to 4, where z is a complex number, and divides the region mod of z minus 3 less than or equals to 1, which is a circle, into two parts of area alpha and beta. Then we need to find mod of alpha minus beta. So one mod of z minus 3 less than or equals to 1, it is a circle with a center 3 comma 0 and radius is equal to 1. So we can say 3 comma 0 is the center and the radius is 1 unit. So 1 unit means here we can say 2 comma 0 and here 4 comma 0. And area of the circle pi r square, that is pi into 1 square, that is pi. Now let us consider for another curve, put z is equal to x plus iy. Then z bar is equal to x minus iy. Now we have z times of 1 plus I plus z bar times of 1 minus I is equal to 4. So we can write x plus iy times of 1 plus I and x minus iy times of 1 minus I, which is equal to 4. So on simplifying, you can get x plus iy plus ix minus y plus x minus iy, and again minus ix, so minus y. So here ix and ix get cancelled, and iy and iy gets cancelled, x plus x, that is 2x, and here y minus y, that is 2y, so 2 times of x minus y, which is equal to 4. So we got the line equation x minus y is equal to 2, or we can say x upon 2 plus y upon minus 2 is equal to 1. So x intercept is 2 comma 0 and y intercept we can say minus 2. So here is a line equation. So the locus of this curve is line x minus y is equal to 2, and when x is equal to, substituting here the circle equation, we have x minus 3 whole square plus y square is equal to 1. So substituting, y is equal to x minus x is equal to 2 plus y or y is equal to x minus 2. So we can write x minus 3 whole square so we can write x square minus 5x minus 6 is equal to 0. So x square minus 2x minus 3x minus 6 is equal to 0, or x taken common x minus 2 minus 3 taken common x minus 2. So we're getting x minus 2 into x minus 3. So we can say that another line, it cuts at the point x is equal to 3. So we can say this is the point when x is equal to 3. So y is equal to 1. So here is the point 3 comma 1. Means you can see it is perpendicular. So here 1 unit and here also 1 unit. So let us consider this is the point P, this is the point Q. Now area of triangle CPQ, which is equal to half into, so 1 into 1, that is 1 square units, and area of the sector is equal to 1/4 of it, that is pi by 4 for smaller portion, and for the bigger portion it is 3 pi by 4. So we can say the smaller region is area of the smaller region, so this green part, area of the smaller region is equal to, so we have total pi by 4 area of the sector, and we have to remove the area of triangle, so you'll get 1 by 2. So pi by 4 minus 1 by 2 is the area of smaller portion. Similarly, area of smaller region is area of larger region. Larger region is here, so we can say 3 times of pi by 4 and area of triangle CPQ, so that is plus half. And now the difference, this is alpha and beta, so mod of alpha minus beta is equal to pi by 4 minus 1 by 2 minus 3 pi by 4 minus half. So we can write pi by 4 minus 3 pi by 4 is, that is minus 2 pi by 4, and here minus 1. Since there is a mod, we can write 2 pi by 4, that is pi by 2 plus 1. So pi by 2 plus 1, which is option B. So we can go with an answer B. 1 plus pi by 2 is the required answer. The sum of all values of theta belongs to 0 to 2 pi, satisfying the equation 2 sine square theta is equal to cos 2 theta and 2 cos square theta is equal to 3 sine theta. So we know that cos 2 theta is equal to, in terms of sine, we can write 1 minus 2 sine square theta. So in the first equation, we can write 2 sine square theta is equal to 1 minus 2 sine square theta, or else we can write 4 times sine square theta is equal to 1. So sine square theta is equal to 1 by 4. So sine theta is equal to plus or minus 1 by 2. So coming to second equation, 2 cos square theta. So we can write cos square as 1 minus sine square. So 2 times of 1 minus sine square theta is equal to 3 sine theta, or we can write it as 2 minus 2 sine square theta is equal to 3 sine theta. 2 sine square theta plus 3 sine theta minus 2 is equal to 0. So factorizing, we can write 2 sine square theta and 3 sin theta we can write 4 sin theta minus 1 sin theta minus 2 is equal to 0. So 2 sin theta taken common. So we can get sin theta plus 2 minus 1 taken common. Sin theta plus 2 is equal to 0. So sin theta plus 2 into 2 sin theta minus 1 is equal to 0, which implies sin theta is equal to negative 2 or sin theta is equal to 1 by 2. Sin theta is equal to negative 2 is not possible because the range of sin is minus 1 to plus 1. So we can say this is not possible. So sin theta is equal to plus 1 by 2. So from 1 and 2, from A and B, so we can say the solution as sin theta is equal to 1 by 2 from A and B. And since it is 0 to 2 pi, so sin is positive in the first quadrant and second quadrant. So we can say one solution is sin theta is equal to sin pi by 6, or we can say sin pi minus pi by 6, that is sin second quadrant, so pi by 6. So we can say the solution is theta is equal to pi by 6 and pi by 6, and the sum of the values, sum of all values of theta is equal to, so we can write pi by 6 plus 5 pi by 6, that is 6 pi by 6, which is equal to pi. So pi, which is option 1, we can go with an option A. Given alpha theta and beta theta are the distinct roots of the quadratic equation 2x square plus cos theta of x minus 1 equals to 0 for theta belongs to 0 to 2 pi. If small m and capital M are the minimum and maximum values, then what is alpha power 4 theta plus beta power 4 theta? And also we need to find 16 times of m plus m. So let us simplify and find alpha power 4 plus beta power 4. We know sum of the roots is equal to, for quadratic equation, ax square plus bx plus c equals to 0. Sum of the roots alpha plus beta is equal to minus b by a, and product of the roots alpha beta is equal to c by a. And alpha power 4 plus beta power 4 we can write alpha square whole square plus beta square whole square. A square plus b square we can write it as a plus b whole square minus 2 times of alpha square beta square. So alpha square plus beta square we can write it as alpha plus beta whole square minus 2 alpha beta the whole square minus 2 times of alpha square beta square. So let us simplify here. So alpha theta plus beta theta, sum of the roots is equal to minus b by a, that is minus cos theta divided by 2, and product of the roots alpha theta into beta theta is equal to c by a, that is minus 1 by 2. And we have the relation alpha power 4 theta plus beta power 4 theta is equal to alpha theta plus beta theta whole square minus 2 times of alpha theta into beta theta, again the whole square, minus 2 times of alpha theta square and beta theta square. So we can write alpha theta plus beta theta is minus cos theta by 2 whole square minus 2 times of minus 1 by 2 the whole square minus 2 times of alpha theta means minus 1 by 2 whole square. So we can simplify and write cos square theta by 4 minus, so here 2 minus 2 into plus, this is plus 1 whole square minus, and here 2 into 1 by 4, that is 1 by 2. So we can write here cos square theta by 4 plus 1 whole square minus 1, 1 by 2. So this is alpha power 4 theta plus beta power 4 theta. We know that cos theta lies between minus 1 to plus 1, and cos square theta lies between 0 and 1. So for minimum value, we take 0, and for maximum value we take 1. So for m, to find m, so let us consider cos theta is equal to cos square theta is equal to 0. So we can write alpha power 4 theta plus beta power 4 theta is equal to 0 plus 1, 1 square minus 1 by 2. So 1 minus half is 1 by 2. So we can say small m is equal to 1 by 2, and capital M, for capital M we consider cos square theta is equal to 1. So we can write 1 by 4 plus 1 whole square minus 1 by 2, which is equal to 1 plus 1 by 4 is 5 by 4. 5 by 4 whole square minus 1 by 2, that is 25 by 16 minus 1 by 2, that is 25 minus 8, 13 by 16. Sorry, 25 minus 8 is 17. 17 by 16 is capital M value. So now we need to find 16 times capital M plus small m, that is 17 by 16 plus small m value is 1 by 2, or 16 times 17 by 16 plus 8 by 16, that is 16 into 25 by 16. So the answer is 25. So 25, which is option B. In a group of 3 girls and 4 boys, there are 2 boys B1 and B2 are specific. The number of ways in which these girls and boys can stand in a queue such that all the girls stand together, all the boys stand together, but B1 and B2 are not adjacent to each other. So here are the two cases can arise. The first case, all the 3 girls are here, and then followed by the boys, in which B1 and B2 are not adjacent. So let us mark first the other 2 boys, that is B2 and B4, having gap in between them, so that we can see there are 1, 2, 3 gaps. So in these 3 gaps, these 2 boys can be placed in either 3p2, or we can say 3c2 into 2 factorial. So finally we can say that the number of ways these 3 girls can be arranged is 3 factorial into, and the boys B2 and B4 we can write in 2 ways, and this B1 and B2 can be done in 3c2 into 2. So that is 3 factorial is 6, and here it is 2, and here 3c2 value is again 3 into 2. So we can write 2 3s are 6, 6 2s are 12, 12 6 are 72 ways. In 72 ways we can arrange the first girls and then boys. Similarly, in the second case, in the case 2, girls will be standing at the back, the 3 girls, and boys here B2 and B4 can be placed here, so that we'll have 3 gaps, 1 2 3. So the maximum possibility can be done here. So 3 gaps are there where B1 and B2 can be placed separately, so that again the same way these 3 boys can be B1 and B2 can be placed in 3c2 into 2, and B2 and B4 can be done in 2 ways, and these 3 girls can be done in 3 factorial ways, so that we can write again 72 ways. So total from both the cases we can say 144 ways. So 144 is the answer, which is option C. Given vertices A 6 comma 8, B 10 cos alpha minus 10 sin alpha, and C minus 10 sin alpha and 10 cos alpha of a triangle. Then also L A comma 9 and G H comma K be the orthocenter, and G centroid H comma K respectively. Then we need to find 5A minus 3H plus 6K plus 100 times sine 2 alpha. And it's very clear from the diagram. From origin, distance from origin to the point B, that is under root of 10 cos alpha whole square plus 10 sin alpha whole square, will be same as the distance from origin to the point C. So these two are same, and also the distance will be same as 0 to A, that is OA, which is equal to under root of 36 plus 64, which is equal to 10 unit. The same units, OB is also 10 and OC is also equals to 10. So here we can say origin is the circumcenter. So we can say origin 0 comma 0 is the circumcenter, and we know that point centroid divides the orthocenter and circumcenter in the ratio 2:1. So from here we can write H comma K is equal to 2 times of origin plus 1 times of A divided by 2 plus 1, that is 3, comma, and again 2 times of 0 plus 1 times of 9 divided by 3, that is H is equal to A by 3 and K is equal to 9 upon 3 is 3, or 3H is equal to A, K is equal to 3. And also now the centroid from the triangle ABC, we can write 6 plus 10 cos alpha minus 10 sin alpha divided by 3, which is equal to H. Centroid x coordinate is H. So that is 10 cos alpha minus 10 sin alpha is equal to 3H minus 6. So that is A minus 6. And also its y coordinate, we can write 8 plus minus 10 sin alpha plus 10 cos alpha is equal to upon 3 is equal to K. We can write minus 10 sin alpha plus 10 cos alpha is equal to 3K minus 8. 3 value, K value is 3, so 3 3s are 9 minus 8 is 1. So here from A and B, 10 cos alpha minus 10 sin alpha, and here 10 cos alpha minus 10 sin alpha. So therefore we can say from A and B, we can say A minus 6 is equal to 1, which implies A is equal to 7. So we got the value of A is 7. And now to find the value of angle, we have 10 times cos alpha minus sin alpha is equal to 7 minus 6, that is 1. Squaring on both sides, we get 100 times cos square alpha plus sin square alpha minus 2 cos alpha sin alpha is equal to 1 square 1. Cos square alpha plus sin square alpha is 1. So 100 times of 1 minus 2 cos alpha sin alpha is sin 2 alpha, which is equal to 1. So we can write 1 minus sin 2 alpha is equal to 1 upon 100, or sin 2 alpha is equal to 1 minus 1 by 100, that is 99 by 100. So the value of sin 2 alpha is 99 by 100. Now let's find 5 times A minus 3 times H plus 6 times K plus 100 times sin 2 alpha. So we have 100 times sine 2 alpha is equal to 99. 100 times sine 2 alpha is 99. And here 5 times of A value is 7 minus 3 times of H value is 7 by 3, and again plus 6 times of K value is 3, plus 100 times of sine alpha is sine 2 alpha is 99. So that is 35 minus 7 plus 18 plus 99, which is equal to, the calculation will go 145. So we can go with an answer 145. Let the distance between two parallel lines be 5 units. So these are the two parallel lines, and let us consider the distance is say mn, so that mp is equal to 1 unit. The point P lies between the lines at a unit distance from one of them, and so that Pn is equal to 4 units. An equilateral triangle PQR is formed such that Q lies on one of the parallel lines and while R lies on the other. Then we need to find the square of QR, or square of the side of an equilateral triangle. So let us consider an angle theta here, PRM, so that here it comes 90 minus theta. So 90 plus 60, 150 minus theta. So the remaining angle can be taken from 180 is 30 plus theta. So let us consider the triangle PMR. It's a right angle triangle. Angle M is equal to 90 degrees. So from here we can say sin theta is equal to opposite, that is PM divided by PR. PM value is 1 upon PR value is nothing but 1 of the side. So here we can say PR is equal to 1 upon sin, that is cosecant theta. And also from triangle PNQ, where angle N is equal to 90 degrees, so we can say cos 30 plus theta, which is equal to adjacent, that is 4 divided by hypotenuse, that is PQ. So here we can write PQ is equal to 4 upon cos of 30 plus theta. Since PQ is a side and PR is also side, it's an equilateral triangle. Since PQR is equilateral, we can equate the sides. PQ is equal to PR, that is cosecant theta, that is 4 upon cos of 30 plus theta is equal to PR value is cosecant theta, that is 1 upon sin theta. Or we can write 4 times sin theta is equal to cos of 30 plus theta. So 4 times sin theta is equal to cos A plus B formula, we can apply cos A cos B minus sin A into sin B. Cos 30 is root 3 by 2 cos theta minus sin 30 is 1 by 2 sin theta. Or here 4 plus 1 by 2, that is 9 by 2 sin theta is equal to root 3 by 2 cos theta. So we can write sin theta by cos theta, which is equal to root 3 upon 9, that is tan theta is equal to root 3 upon 9. So when tan theta is equal to root 3 upon 9, so we can say cosecant theta is equal to cosecant square theta is equal to 1 plus cot square theta. So which implies cot theta is equal to 9 by root 3. So 1 plus 9 nines are 81 by 3, that is 1 plus 27, 28. So cosecant square theta is equal to 28. So cosecant theta is equal to square root of 28. Therefore cosecant is nothing but one of the side. Therefore QR is also cosecant theta, that is root 28. QR square is equal to root 28 whole square, that is 28. So we can say the answer is the side square of the side is 28. Given that summation r is equal to 1 to 30, r square 30 cr whole square upon 30 cr minus 1 is equal to alpha into 2 power 29 when we need to find alpha value. So this can also be written. Let us consider the left hand side. Let us simplify it. R square into 30 cr into 30 cr upon 30 cr minus 1, where r is equal to 1 to 30. So we know that NCR by NCR minus 1 is equal to n minus r plus 1 divided by r. So this is one property. So let us apply here. So we can write summation r square into 30 cr into 30 minus r plus 1, that is 31 minus r divided by r. And again we have another property. NCR is equal to n upon r into n minus 1c r minus 1. So let us apply this property here. So we can write summation r square into 30 cr means n is equal to 30. So we can write 30 divided by r into 30 minus 1, that is 29c r minus 1 into 31 minus r divided by r. So here r into r square gets cancelled. So r is equal to 1 to 30. So here we can write summation r is equal to 1 to 30, 30 into 31 minus r into 29c r minus 1. Let us split these terms into 2. Or this 31 minus r we can also write it as summation r is equal to 1 to 30, 30 into 30 minus of r minus 1, which gives 31 minus r, because 29c r minus 1 is there. So I want to express in terms of r minus 1, so that now we can split into 2 terms. Summation 30 into 29c r minus 1 minus summation of 30 into r minus 1 into 29c r minus 1. So here 30 into 30 and summation of 29c r minus 1. So when r is equal to 1 to 30, it's a summation, we can say summation NCR is equal to 2 to the power n, when r is equal to 1 to n. So when r is equal to 30, we'll be getting 30 minus 1, that is 29. So 29c29, you will be getting 2 power n. So we can write 2 to the power 29 minus here summation 30 into r minus 1. Let us try to cancel this r minus 1 again by applying the property 29c r minus 1. Use this property again. So we can write 29 by r minus 1 into 29 minus 1 c, 29 minus 1, that is 28c, r minus 1 minus 2, that is r minus 2. So we can cancel this r minus 1. So we can write 30 into 2 power 29 minus 30 into 29 into the summation of 28 is r minus 2, where r is equal to 1 to 30, but when r is equal to 1 it's not valid, so we can substitute from r is equal to 2. So when r is equal to 2, so we can start from 0, 28 c naught 2, and when r is equal to 30, 28 c 28. So it is also the same summation 2 power n, so we can apply 2 to the power n is equal to 28 here. So here in this case r is equal to 0 to insert. So that we can simplify and write 30 into 2 to the power of 20, 28 taken common. So we can write 30 into 2 minus 29. So which is equal to, we can also write 2 power 29 into 15 into, and here 30, 60 minus 21, that is 31. So that is 2 power 29 into 31 into 15 will give 465. So here when comparing with RHS, alpha into 2 power 29, so we can say alpha value is 465. So the value of alpha is 465. This is the answer.